Welcome to our what's going to be our last event of the Urban Growth Seminar. We'll have a new series in the spring semester, and we'll have a new list of speakers. I'm Trinit Banerjee. I'm the member of the faculty here, and I also am the director of the graduate programs of urban planning and development. We're jointly co-sponsoring this seminar series with the Center for Sustainable Cities. We'll tell you a little bit more about that. And I'm very pleased to have our speaker today. Those of you who are in planning and public policy management, you should be hearing more and more about this concept of smarter cities and how to make cities smart. It's not that we're not smart already, the planners. It's just the cities need to be smart, right? So, and a lot of that initiative coming from the private sector, the corporate sector, and so here today's talk speaker will begin to give you some overview of some of the ideas that they're working with. And Mr. Justin Cook, who is the manager of foundational research of the IBM corporate brand. His group focuses on executing challenging projects to advance IBM Smarter Planet thinking and leadership skills. So they're really kind of in the leading edge of the IBM. I guess they're like the guys who are given a lot of room to think creatively, I guess.
Yeah, we'd like to think so.
Right. So we'll hear more about that. So one such project was in a partnership with the Mayor and Urban Planning Office of Portland, Oregon, which is known for the growth management initiatives, and the IBM System Dynamics for Smarter Cities. So he's going to sort of draw on this kind of a systems thinking models of the long-term dynamics of a broad range of city functions and the complex system of systems. And so previously I'm going to sort of be a little bit, abridge this a little bit. Previously, Mr. Cook was the business development manager for IBM Research, working to commercialize sustainable technology assets. He drove opportunities in data center energy efficiency, water desalination, and solar power. He also held the position of global business development executive global technology systems, working to launch a new venture in the small and medium business market. He has a bachelor's degree in economics from Wharton School of Pennsylvania, and an MBA from the MIT School of Management, my alma mater. So with that selection, I'm very, very pleased to introduce Professor Justin Cook. I should also introduce Professor Hilda Blanco, who will be the discussant. Many of you know Professor Blanco. She is actually the co-sponsor of this seminar series, and she's the acting director of the Center for Sustainable Cities. A big name in the climate change world. She is a member of the new report of the IPCC that's coming out in 2014. She's one of the lead authors on one of the chapters on urbanization and growth. Urbanization, urban planning, of the volume on mitigation. So we're very pleased to have Professor Blanco be the discussant. So we usually give our speaker about 30, 40 minutes.
Okay.
And then we have a 10 minutes discussion, and then we have Q&A from the audience. Okay?
Terrific.
Mr. Cook.
Thank you. I'd like to thank the organizers and the sponsors for inviting me here today to represent IBM and to talk about our systems thinking and smarter cities initiatives. What I'll do is I'm going to talk a little bit about the kind of larger initiatives that IBM has around smarter cities. I'll spend a little bit of time on systems thinking and why we think it's so important as a way to engage with and manage cities. And then I'm going to talk a lot about a specific project that I ran in Portland, Oregon with their mayor and Bureau of Planning and Sustainability on setting a new 25-year strategy. Now, I'm part of, as was mentioned in the introduction, a small team within IBM called Brand System Strategy. And we're only about 8 folks, but we even have an LA representative. We have Amy Hermes in the back here. And what we've been working on is developing leadership lessons for smarter cities. We'll go over that a little bit, but the one I'm going to focus on, of course, is systems thinking. So we've all probably heard that on Halloween just a few days ago, we crossed a milestone in terms of population. There are now 7 billion people on the planet. But not that long ago, we passed an equally important milestone. In 2007, for the first time, there were more people living in cities than were living in rural and other areas. And that's only expected to increase. More and more people are moving to cities. In fact, some countries are even ahead of this trend. I was just in Bogota, Colombia about 2 weeks ago. And due to several reasons, they have about 80% of their population living in cities at this point. So this is a trend that's happening everywhere. And when it comes to cities, you know, why are these kind of entities of anything that we could focus on such a key focus for a lot of our goals around sustainability? Well, I've already talked about part of it. One reason is that's where all the people are. So if we're going to, you know, affect anything that has to do with people and the way that we impact our environment, we have to be focused on cities. But there's something else that's pretty special about cities in terms of their scale. They're small enough that you can actually accomplish things within them, yet they're big enough that those things that you accomplish are significant. So if we want to make, you know, kind of planetary-wide change, we need to figure out this unit that we're going to focus on. And if we focus on cities, we think that has the best opportunity to not only address where the people are, but to affect things at the right scale. So I've heard that the best way to start a speech is to talk about the fact that you would like to tell people a story. And the reason is that no one wants to hear a speech. Everybody's up for a good story. So my challenge, though, is that we have over 2,000 really good stories from the work that we've done with our clients in the Smarter Cities space. And that affects everything from transportation to energy and utilities to water. We've helped with congestion in Stockholm. I have a colleague that's been working with the city of Dubuque on a lot of their smart water initiatives. Right after the earthquake in Japan, I was in Sendai, the city that was most affected by the tsunami, as far as the largest city affected by the tsunami, working with them on resilience. So at IBM, we have a pretty broad swath of knowledge about how cities are going about championing ways of becoming smarter and working better. And from that, we've started to discern what are some key principles about this thing that we're calling SMART. And because we're IBM, we have to have an acronym for it. We call it the 3 I's. So that's being instrumented, interconnected, and intelligent. Instrumented because there are so many things out there right now that are helping us grab data. Everything from the cell phone in your pocket, which has a GPS and a camera to take pictures of potholes, to things like Galway Bay, where we've placed sensors in the water to help monitor the condition of the bay. So the world is becoming increasingly censored, so we're grabbing more of the data that's happening out there. It's also interconnected. So we're not just having this data sit in different silos, but because we're doing things like moving systems to the cloud and other ways that we're integrating data as society, we're now becoming much more interconnected. So these data points are touching each other. And intelligent. Now that you have all this data, you have it in one place, you have this opportunity to add intelligence to the type of decision making that's made and make better decisions. But with any kind of change, there comes certain challenges. So for mayors, city planners, CEOs of corporations, et cetera, everyone that's participating in this kind of smarter world are going to be facing certain leadership challenges they have to contend with if they're going to be successful in this new environment. I'm going to tell you about 4 of these that our team's been working on. So the first challenge would be building constituencies. If you have people with greater interconnection and the scale of projects that you're trying to do is larger, you're going to need to get very good about smart ways of building constituencies to move some of these processes forward. So a smarter leader on a smarter planet would need to be able to build constituency. Another factor that's happening, and you can see this in cities especially, is that this same kind of interconnection is allowing individual decision makers, individual citizens, individual consumers to both, be able to and have the expectation of being able to participate in these decisions and these networks. So when we're putting systems out to the world, we need to be thinking about how the kind of consumer behavior or citizen behavior end of things are going to manifest themselves and design accordingly. So the next step is also building a culture of analytics. We have a study at IBM that just came out today that was joint between our Institute of Business Value and MIT Sloan Management Review that looks at all of these issues that come with analytics. And analytics, of course, is a big part of the intelligence area here. It turns out that the kind of logistics, the technology, the cost, that all is hard to do and important, but the biggest factors are the cultural change issues that come with trying to get an organization to be more analytical and more analytically driven. And then, of course, what I'm here to talk about today, for the most part, is systems thinking. How to recognize the complex, interconnected systems that are all around us, and how to address decisions in that environment. So in order to talk about systems thinking, let's talk about, what is a system? What are we talking about when we say system? And it can be very basic. In fact, the example I'm going to give is filling up a glass of water forms a system, right? So, what are some of the aspects of systems? Well, they have elements. There's all the different components that are in the system, like the faucet and the water flowing out of the faucet. There's interconnection. These elements aren't just standing alone. They relate to each other in one way. So, the faucet position controls the water flow. The amount of water that's flowing obviously has a relationship with the current water level in the glass. And there's purpose. There's something that the system's doing. It doesn't mean that it's purpose as in, we've assigned it purpose or it has a will of its own, but there's some purpose, some goal that a system is working to. In this case, you're trying to fill up the glass of water without spilling it. So just something as simple as a glass of water, filling up a glass of water is a system. But, a system never really stands in isolation. In fact, the boundary setting for these systems can be one of the hardest things to do, is figure out, what do I include in my system and what do I not. But obviously, our glass of water system is connected to a much bigger system. It's not just the plumbing going into the house, but it's the entire hydration cycle of water evaporating and raining back down and clean water reserves and dirty water reserves, et cetera. Now, sometimes people forget this, and it's unfortunate, but the most important part of systems that we're dealing with, especially in cities, and the places where the most interesting things happen, is when people get involved in the system. So if you're looking to design some kind of change, you have to consider how people are going to behave in the system, how they're going to react, what their needs and goals are. And of course, this gets us talking more towards cities. So our water system, which in itself seemed to be very complex, is connected to many other systems. So we have healthcare, utilities, transportation, education, government. All of this comes together in our cities. So this is kind of back to my point about why cities are so important. It's where not only where the people are, but it's where it all comes together. And you can start to expand the model looking at, water and utilities, water and electricity. It takes electricity to move water around. It takes water through steam and turbines to make electricity in most cases. All of these things are very interconnected. And it's important to understand them as a system. So just as a kind of quick way to make this a little bit more real, let's just consider 4 parts of a city. 4 things that happen. We have our public safety and crime issues in the city. We have public transportation. We have emissions, and we have something like education. How are these things related? How do these things come together in cities? It's not always obvious at first, but there's quite a lot that comes into play. For instance, if people are taking public transportation and the public safety isn't sufficient, people really don't feel like taking public transportation as much if they don't feel safe. You have to feel safe to be able to take public transportation. And if a certain part of the population doesn't feel safe and they reduce ridership in public transportation, oftentimes public transit has these big fixed costs they have to cover no matter what. So they're left with a situation of either neglecting some things that they can, like neglecting maintenance, et cetera, or raising fares. And either one of those things makes it even less attractive to take public transportation. You can get into one of these death spirals, actually, where things just kind of get worse and worse for your public transit system. And if people don't like public transit, one thing that's going to happen is that the relative attractiveness of driving might go up. You might end up with more people driving to the places they want to get to, adding to more emissions. Or, people have to get to school, especially, students that can't drive. A lot of people actually rely on, in different cities, public transit to get to school. And if you're increasing the barriers to getting to school, you can have long-run effects in terms of increased absenteeism, increased delinquency, and you might feed right back into your public safety problem. So all of these things, once you get through a few layers, can be highly interconnected. So, I've talked about interconnection so far. But now I need to not neglect the fact that this systems view, this complex interconnected system and how we view this, isn't just about saying everything's tied to each other. Systems themselves, complex systems, are strange beasts. They don't work the way that we think things work. They're counterintuitive. And I've got a list of some of the reasons why they're counterintuitive. We can go through a few, but the big takeaway is that our intuition, the way that we think things will work, tends to break down when it's talking about complex systems. So one thing, a lot of the change that happens in a complex system can be exponential, nonlinear change. And we as people, intuitive people, we're not very good at estimating nonlinear things. Cause and effect can be greatly separated in time. When we see an effect, we tend to look at what just happened right before it to see what caused it. In systems with all of this interconnection and change that things pass through, it could be decades in between the actual cause and the effect that gets manifest. And it's hard for policymakers to attack something that happened 10 years ago or prove that it is the cause. There are counterintuitive relationships. Sometimes, a classic example is road congestion. So one of the classic techniques to battling road congestion as well is put more capacity out there. If there's congestion, let's put more capacity, let's build more roads. Turns out that doesn't solve congestion at all. It just brings in more drivers because the relative attractiveness of driving has gone up. So you end up with the same congestion problem across more roads. Some actions are irreversible. If you're consuming resources that's twice the replenishment rate and you end up extincting something, you're not coming back from that state. And probably the biggest with cities is policy resistance. So sometimes our best intentions of attacking a certain symptom and a problem is like squeezing a balloon. You squeeze down on one part of it and it pops up somewhere else. And that's part of the dynamic nature of systems. So when we say we need this view of systems thinking, it's not just about, everything's connected. It's about thinking about these properties of complex systems. And I'm going to leave you with two things that explain a lot of this strange behavior in systems. One is that systems are built on feedback. There's two different kinds of feedback loops that drive a lot of the behavior in systems. And then the role of delays is also very important in systems. So when we talk about feedback, there's these two loops. There's a reinforcing loop, something that continues to build on itself. And so the kind of throwaway example I like to give that I stole from MIT is chicken and eggs. The more chickens you have, the more eggs they're going to lay, the more eggs, the more chickens. And this kind of cycle just continues to perpetuate itself. Except for almost always in systems, there are balancing loops. And so the more chickens we have, the more road crossings there's going to be, and then fewer chickens after that. So there's this feedback that happens, and just about anything that you look at, there's these two kinds of loops that are driving the behavior systems. The other thing is the delay. How long does it take some of these things to happen? And what results as a result of these delays? So my favorite example actually kind of happened to me today. 26th floor of the hotel room. You turn on the shower, you crank it up, hot. You feel it, it's still not hot. So you turn it up a little bit more, still not hot. You see where I'm going. Eventually it's scalding hot and you crank it way back down. And the reason this is happening is there's a delay between the system state and my information about the system. So I'm not understanding that if I wait long enough, the heat will catch up, and instead I tend to overreact. That's where you get these kind of oscillating behaviors in systems. So feedback loops, delay. They'll tell you a lot. All right. So now to the project that we did with Portland, Oregon. So I think that's all the theory I'm going to throw out there, and let's talk about how this played out in a real city. So Portland, throughout the last 2 years, they've been going through what they call the Portland Plan, and this is a 25-year new city strategy for their plan. That they set this document out, they get tons of public input into what it should be about, what their goals are. They have lots of charrettes and other public workshops to get input to this. And then they have their 25-year strategy mapped out. Now what Portland was seeing is that, you can imagine when there's a document that's going to be set for the next 25 years, every part of the city, every interest group, every concern, every department wanted to make sure that their needs and concerns and their pet policies, for lack of a better word, are embedded in this plan. And the leadership that was putting together the Portland Plan knew that there's certainly not enough resources, there's not enough ability to focus on all of those goals. Can we identify policy actions we could take that would address multiple issues at the same time, address multiple concerns? And if not, can we figure out a way how to prioritize some of this to have the biggest impact on the city? At IBM, we were working on something that had been in the works for about 6 months. We'd been starting to develop a model of city interconnection from our own experts from around IBM. So we have people that have worked with cities and transportation, people that have worked in water, electricity, you imagine. And we'd started to develop a rough model, but we knew that it was going to take, rolling up our sleeves and putting it in play in a real city in order to figure out, if the thing worked or not and what needed to be changed. Basically, we wanted to know everything that was wrong with it, and we knew there would be things wrong with it. So with Portland, we set up this program with the mayor and the Bureau of Planning and Sustainability in Portland, their chief planner, Joe Zender, who throughout the course of the next year, we worked closely together with them and with subject matter experts from all over the city. We had about 70 different subject matter experts from different areas weigh in on this model to create what, at the end of the day, we're calling a systems thinking tool. And I want to emphasize that, the type of modeling that we've done in Portland, a very general model of the city, is nothing that they would use to make a firm decision on. They're not going to run the scenario and say, if we add 26.8 more miles of sidewalk, we're going to affect the amount of walking, X percent. But what we are trying to do is help the city of Portland be systems thinkers, help these leaders plan and account for these kind of strange properties of systems. The two things that this tool allows them to do, one is to visualize interconnection. So they can take any part of their city, hone in on it and say, okay, what are the things that are driving this and what are the things does it drive? So the sidewalks, what things cause, sidewalk usage and what does sidewalk usage cause? The other way that you can do this in this visualization is you can do what we'd call an A to B view. You can say, how does one part of the city affect another? And have it visualized. I'm going to show you what that looks like. The other thing that they can do with this tool is to run scenarios. So they can make a change, something different than what Portland was forecast to be over the next 25 years, and see how that ripples out. So this is a screenshot from what the Bureau of Planning and Sustainability would see from their model. And so we have the city divided up into 12 major areas, everything from, at the top, housing and real estate, the people, the quality of place, all the way around to things like transportation, design and planning, emissions, et cetera. And this diagram is not actually the model itself. The model itself, these distinctions don't actually exist. It's all just one big model. But we can grab parts of it and slap these kind of labels on it to help people navigate into the model. And so what can be done on this model is you could click on any one of these bubbles, and see what some of the key variables are for that city. So if you clicked on the economy, you'd see city GDP. If you clicked on wellness, you'd see all sorts of both health and societal wellness indicators. And they can also click on any of these joins. Like if you clicked on the join between transportation and wellness, you would see some of the things that affect that. So let's go into that. Now what I've done is I brought up now we're in the real model. So we've clicked through the interface, and we're now looking at an interconnection point. We're going from active trips on this side. And so the way that Portland defines active trips is walking, biking, public transit, anything that requires some kind of exercise, and its effect on a healthy population. And we're in the most simple version of this. You can actually crank up the complexity going on this side. And we see that there's this interesting relationship between active trips and obesity as one of the mitigating factors that tie active trips to a healthy population. So a user could zoom in on that trip, just kind of isolate the fact that active trips has a causal chain relationship to obesity. And then with systems, I'm always looking for these feedback loops. So it's interesting that the relationship works this way. What I do then is I toggle it and say, does the relationship flow back the other way? There's a relationship between obesity or between active trips and obesity. Is there a relationship between obesity and active trips? Does it flow back? And in this case, yes. The idea here, if you follow the map, is that the kind of higher obesity levels you have, the less attractive amongst competing modes that active trips would be relative to, say, driving trips. And so you get a shift from driving, or from walking and biking more towards driving. Or looked at in the other way, if obesity levels were brought down, you would start this virtuous cycle. You would start to see more walking and biking. Because walking and biking creates exercise, you further decrease obesity, and so on and so forth. You can also start to then think about, okay, I've got this positive feedback loop, and I know this, I feel comfortable about these connections. What else is this attached to? And if you go through enough spaghetti, you can see that, obviously, the obesity has a carbon impact. There's a relationship between, since there's a relationship between obesity and driving has a relationship to carbon, you can now start to, I mentioned constituency building, you can start to see where are some of the natural constituencies that may reside in this city. How can I convince the obesity people and the carbon people that they actually share a common goal? Or, how can I, now that I know that there's this positive feedback loop, how can I jumpstart this? How can I get this thing going in motion and going in the right direction to improve my city? And you can then argue out, do I try and attack obesity as the way to get this virtuous cycle moving? Or do I try to do something that increases the number of active trips, like changing its attractiveness? And that's where some of the smarter cities kind of technologies could come into bear. For instance, our congestion charging, like I mentioned in Stockholm. If you add a price to driving a vehicle into a downtown area or some other congested time, you can start to shift some of the attractiveness and get some extended benefit through activating some of these loops. The other thing that can be done through this simulation is to change something and see how that ripples through and affects. And this is not quite as dramatic as a screenshot, but what you can do, you can choose just about anything in this model and change it just by drawing the line differently. So in this case, we have a 25-year time span starting in 2010, and I'm looking at the amount of investment that flows into my city from outside. And instead of, in the base case, just keeping it at a static 1 million a year, 1 billion a year actually, I've slowly ramped that up over the course of the 25-year period and said, what would happen if we somehow get this outside investment? The next thing that the simulation does is it takes you to a consequences page. So there were about 50 consequences that the city of Portland was most interested in. What this does then is it takes you back to the consequences page. It shows you, out of those 50 in kind of ranked order, what did that change affect the most? And some of the things are obvious, like at the top, obviously investment is a component of city GDP. You'd expect that to change. But some things are not quite as obvious, or at least not as immediately obvious, like the fact that you're going to have more electricity usage in your city. And it makes, if you have economic growth, that's one of the drivers of electricity consumption. If I want to explore that further, I can actually click on one of the links here, and it'll bring me into that dynamic view. So before I close, just a quick time check. There was a few other slides I could show if there's time. Otherwise, I'm going to close things off, and we'll get back to it in the question and answer period. Have time? Fantastic. So I'm going to come back to this slide. We get the bonus material. Okay. I mentioned systems, mentioned that they behave strangely, mentioned that that's caused by feedback and delay. Now, what can we do about it? There's all sorts of ways of intervening in systems. And in fact, this is a list that's adopted from Donella Meadows, who is a big systems thinker and someone that is definitely worth looking up. But she came up with a list that showed, not only a pretty good inventory of the ways of intervening in systems, but she also ranked them in terms of how effective they tend to be in actually making big change. So there's things at the bottom, like constants, parameters, and numbers. So these are the things that we actually hear about the most. Most people spend a lot of their time and political capital focused on making these kind of changes. So that'd be things like, should the gas tax be raised 7 cents? Should we add, one more person to the team? Those kind of changes make a difference, but they don't change anything really fundamental about the system. It still pretty much behaves in the same way. So, we can use, tax incentives to pick on that as a way of debating whether an income tax should be 2 degrees higher or 2% higher or not. But if you want to fundamentally change more of what's going on, you need to get a little higher in the stack. And in fact, I like to focus on changing the structure of information flows and changing the rules of the system as two very, powerful yet kind of tangible and specific things that we can do. And so, to use, I had to explain this when I was down in Columbia a couple weeks ago, and so we used football analogy, soccer analogies, talking about these different things. So constants and parameters, we're talking about, how many soccer players are on the pitch. Do we get 2 points for every goal scored instead of 1? Things that don't fundamentally change the nature of the game. But what if we change the structure of information flows? What if we knew ahead of time the plays that were going to be called by the other team? That kind of thing could radically change what I do out on the pitch. Or what if I change the rules of the system? What if the rule was to score the fewest points? Or if the rule was to capture the other team's net? That really changes the play on the pitch, on the playing field. So that's the kind of change that we're talking about. Or, to be more specific to, kind of smarter cities and the way that we operate. If you think about the structure of information flows, one of the big examples is providing people information about their use of resources. So if we have smart utility meters, if we provide people the information about what they're using, they're more likely to change their behavior. That's the feedback loop that we're trying to add into, put more information out there. Or rules of the system, again to congestion pricing. If we're able to change the rules of the system and say that there is now a price or there is now a process for going downtown at a certain time, that changes the rule of the system and how things behave. Or, in Columbia, they have a lot of problems with this, but, every other day licenses. If you have odd or even numbers on your license plate at your ending number, whether or not you're able to drive that way. Those are the kinds of things that can actually change rules. And I'll leave you then, before I go back to the wrap-up, with just a little bit more commentary on this. So from a structure of information standpoint, you can see that, this is quotes from Donella Meadows, that often it's really just getting rid of these information asynchronicities that can make such a big difference. And the role of technology. So, I like to think, working at IBM, that we're making a big difference. And one of the ways that I see that happening is that it allows for rules to change. By putting new information technology systems out there, you then have a platform to, for instance, internalize externalities. So things that are happening out in the world that were too hard to put a price on before because we didn't have the information or we didn't have an effective way of administrating that, information technology can happen at that point. So I'll just leave you with this, and I think this is appropriate for this audience. You know, we have many ways in which the planet is getting smarter and many different things that we're trying to attack around our world to help make it more sustainable, to help improve how things work. And as systems thinkers, we need to be thinking about the interconnections between these things and the ways to bring this all together so that our whole planet, if you will, operates in a better way. So thank you very much. It was a privilege to come speak with you today, and I'm looking forward to some of the questions.
Well, I'm really pleased to have Justin Cook with us today, and I'm also very pleased that large ICT corporations like IBM have discovered the importance of cities and are helping cities to become more intelligent and to make better decisions through ICT innovations. I think that planners and local policy makers need all the help we can get, for sure. This quarter I've been teaching a course on methods and tools for urban sustainability. And so I introduce students to systems thinking and natural capital valuation, urban metabolism analysis, vulnerability analysis, and other things. And I found out that Justin and his group had just assisted Portland in their planning and sustainability strategy in developing that. And so I was very excited about this. For one, because I was teaching this in an urban planning context. And so we tried to get him here pretty, through various phone calls and so on. So I'm very pleased that you're here. And I was especially pleased with the work in Portland because it really answered one of the questions that a student in the class had posed, which was, well, how do cities actually incorporate these tools into their urban planning process and so on? And of course I knew that that was not the case, but when I heard about Justin's work, I said, well, we have to have him here because he shows exactly what's going on and what could happen in a city setting. Systems thinking, in particular, is not new to urban planning. It was actually quite incorporated into planning theory and urban planning in the early 60s through the 70s, early 70s. It was rather influential in planning, but at that time, it overreached, basically. I don't think we had the computing ability, and also we really didn't have the data for large systems analysis. And already in the mid-70s, one of the planning scholars wrote a very influential article that basically announced the death of the systems approach, a Requiem for large systems, it was called, the article. And so planners basically stepped away from systems thinking. Since then, some planners have pretty much embraced the fact that you have to think in more complex ways and so on. And in particular, the modelers in urban planning, specifically the large transportation and land use models are obviously, complex systems models and so on. but as a whole, planners have yet to rehabilitate the systems approach. And yet, of course, you know, it's very clear that the world is complex and becoming more complex, and that components interact in nonlinear ways and so on, and that systems thinking is really one of the major conceptual tools that we have to understand things in this more complex way and so on, in terms of feedbacks, in terms of leverage points, in terms of delays and so on. But it's been rather slow, and also, I mean, the fact is that as we become more and more conversant with the requirements for sustainability, for dealing with climate change and so on, most of the work in these areas is really cast in a through a systems approach and so on. So it's about time that we began to accept it. I think basically what happened in the 70s and since that time is that we threw out the baby along with the bathwater and so on, and it's time to again begin to incorporate systems thinking into our conceptual set of tools and so on. This issue of incorporating systems dynamics as well as the leadership type of lessons that you've been talking about is extremely important, because planners are very much aware that the problems are not just technical, they're institutional and they're behavioral and so on, but at the same time, we don't systematically focus on these issues. We have a strong tradition of participatory processes in planning, but we don't have a very strong tradition, it seems to me, and Frida can perhaps discuss this further, of really doing solid research in institutional changes and so on. We have left it to others to do that, and this is very important. Of course, this comes from the business background that your approach brings to this subject, because systems thinking, certainly as Senge developed it in the early 90s and so on, it comes out of a business school perspective, and so it's focused as much in trying to shape mental models and so on, and changes in corporations, as it is in really explaining complex interactions and so on. It's not just an engineering or scientific approach, it's as much a business approach. And in a real sense, that's also very welcome for planning. And we have lacked, I think, we have lacked a focus on these aspects of the situations that we deal with. I think in general, I just would like to thank you again for doing this work, and I'm hoping that it's something that will catch in many planning settings as well, because I think we need to begin to think a bit more complexly, in a more complex manner about these issues. Right.
Thank you. I'd like to, too, get back to your point on kind of a requiem for large-scale models, because there's some very important lessons learned that are part of that. Right. It kind of goes back to the example I was showing about systems boundaries. And if you have, you can model your filling up a glass of water at a water faucet, but there's so many other things that's connected to. And pretty soon, if you're trying to model systems, that can get really carried away. There's no way to stop. And so the learning from that is to not model systems. Never try to model a system, model a problem. And that brings us, what replaced the large-scale systems models was small-scale systems models. So the focus then became much more on kind of more manageable or more defined problems you could set the boundaries on better. Now with Portland, we kind of broke a little bit of that cardinal rule. We ended up going back to a large general model that was spanning a lot of the city. But we did so consciously with a very different purpose in mind than a lot of the forebearer models, if you will. Instead of trying to actually come up with something as a policy-making tool, something that was going to sit on the mayor's desk and allow Mayor Sam Adams to make decisions about the city specifically, we cast it as a systems thinking tool. And so the one thing we know for sure is that there is real and important complexity of the city of Portland that is not captured in the model. But we feel like we've cast a wide enough net and have taken an approach that from a training standpoint when it comes to systems thinking, from early warning system, if you will, of looking at a change and seeing what some of the implications might be, we've kind of set some new ground for a larger scale model.
Yeah, no, I think it's very promising way because we've had software on systems thinking available. I mean, there's Stella and I Think and so on, but that kind of software is really more scientifically oriented. And I think the software that you're developing, because it's really developed for the context of local policy making and so on, and focused on cities, could really be influential.
Yeah, and I think one of the changes, as you mentioned, since say the 70s or so, when this was a hot topic, is that the technology has changed, not just in the ability to process, not just in the ability of data to be gathered, but in the interface, the ability for someone to take these models off the desk of the specialists and the modelers and put them into the hands of the end users and decision makers.
That's
so
right.
the interface is a major aspect of the type of change that we're looking at here.
Yes, yes. All right, maybe we should open it up.
We should open up for some questions from the audience. Go with the back.
I'll try to speak loudly because we couldn't hear very clearly here. But so my name is Laetitia Deblon. I'm a visiting scholar here at USC at the METRANS, which is a transportation research center here. And my question is actually related to your last comment about these large-scale models that you don't want to go into anymore, and you have another way of connecting all these different systems together. Actually, I'm very interested in that question. What is actually the level of details you go into when you provide Portland with this fantastic tool for organizing and thinking about the future of the metropolitan area? My area is urban freight, or physical supply chains to supply goods for big cities such as Portland or big metropolitan areas. And for this particular example, which is just one of the many different systems that you presented to us that are all connected. So for this particular system, urban freight or urban logistics, what kind of data do you input? Which level of details do you go into? What kind of information do you get into your model in terms of relationships with retail or the different trends in the urban economies and labor, or all the different aspects that are very related to urban freight? I'm just interested in the level of detail you include in your model for this particular area. Thank you.
Yeah, so you raised several good points, and I apologize if people in the back couldn't hear me. I thought about being mic'd, but I realized that it's also not amplified. I guess it's for the video, so I apologize for that. But so you raised several good points. One of which is how this gets positioned with the city of Portland in terms of what their expectations are. And we learned a lot in this project about how to do that. There's this interesting trade-off between kind of complexity and making the model, so complex as a way of chasing, accuracy that the policymakers are not able to get down to that same level of detail with you. So, obviously transparency is an important bit, but, we knew that. But it's one thing to be open, it's another to model things in such a way that they're so complex as to be impenetrable. So we had some good trade-offs with working with the subject matter experts in the city of trying to model things so they captured enough to be realistic, but not so much that we would lose the people and the confidence and trust of the end users who need to understand it in order to believe it. So one of the things that led us to do, and along with the purpose of the model, is for something like transportation, or even something within transportation, of course, like urban freight, we tried to capture kind of just good enough the models of those systems to represent the major architectures. And because there are models that exist out there that are much more detailed and much better for any given silo or discipline. So, but we tried to do just good enough, and then we spent most of our efforts in modeling out the interconnection between those areas. So we have kind of the skeletal or good enough model of any given subsystem, and spend a lot of time looking at interconnection. So, to intercity freights, I can think of a few things that touch on that, but given the wide scope of our model, there really isn't that much detail about that specific aspect of transportation. One of the trade-offs.
For the Portland project, for instance, I'm wondering how different elements are quantified or measured, whether you rely on existing studies or models and are limited by that, or whether your group is actually doing original research for some of the questions that are asked. So.
Yeah, it's kind of all of the above. And so one of the ways that we kind of bootstrap our model to inform it is these detailed sessions with subject matter experts. So we walk through a process where we get subject matter experts cross-disciplinary in different rooms to address different aspects of the model, map out for us their belief in some of the causal chains. That's one thing that happens. Another is we go back to previous models and previous research. We look at people who've modeled, for instance, the police force or the fire department in a city, and are able to leverage some of their work, or in the case of the health model, some work that the CDC had done. But we also got 10 years worth of data from the city on just about everything that we could in the model, and that's part of how this comes about. We're not doing, the model doesn't kind of crunch that itself. It doesn't try to find the regression coefficients to plug into the model. That gets handled separately. But what we do is we set the model back 10 years into the past under similar conditions and run various scenarios forward as far as what happened in the real world to see how well the model ends up predicting what actually happened as one of the ways that the model gets calibrated. So, so out of the set you gave, it's kind of all of the above, really. It's quite, you have to triangulate in on this thing.
It seems like as you make all these systems more efficient, that the employees, the public servants, are going to be made redundant, or the requirements of them are going to be greater. And I'm wondering how either you or the city is accounting for this.
Yeah. No, so there's always, classically, there's a trade-off in terms of, whether if we put technology of any kind into a process and make it more efficient, if that's the real goal, what does that do to job creation and jobs, either be it in a city context or any other? So, and what we've seen from our research, as well as the research of others, I know there's a new book out by MIT professor Eric Brynjolfsson, if I get that right, that's addressing this specific issue about the role of technology in job competition. Our sense with cities is that there's so many new challenges that cities are being asked to address, and so many new service opportunities and new potentials that are unleashed by this aspect that it wouldn't really have a material impact on jobs. That if anything, more would be needed to address kind of these rising approaches. But to be honest, I don't know the answer to exactly what might change in any given city. especially depending on over how long of time frame that you're looking. So sometimes there may be short-term disruptions that get replaced by additional work, but obviously, as we see in the rest of society too, there can be skill mismatches, and it can, any kind of disruption, any kind of change can cause problems.
Yeah, I would imagine that as the analysis proceeds, that you will identify inefficiencies, and that might result in some unemployment of staff and so on. But the real, I think, value of the work is to provide the decision makers as a whole with a broader understanding of the system altogether. And
Yeah, and
Yeah,
a good
that's
example
not
that
there.
would go to that
Yeah.
would be, we often find that preventative maintenance is better than waiting for something to break. And so we've done a lot of work modeling water pipes in cities. And I know one just broke on Ventura Boulevard or something last night. And so you get a water main break, it causes all sorts of disruption. So we'd be advocating, for instance, doing preventative maintenance, which may cause the city to spend money ahead of when they wanted to, but then they don't spend as much money as they might have overall. Would that have a job impact? I guess theoretically, in the sense that when things break, it requires a larger team and overtime and that kind of thing. But we'd still advocate for preventative maintenance.
yeah.
I have a question. I was sort of curious, since you are kind of, put your talk in the context of this climate change, global warming, sustainability kind of context. So is there a way of measuring the performance of going systems approach by saying, well, the smarter cities are reducing their, if you go this way, if you make the city smarter, that will reduce our footprint, carbon footprint. Is there a way one could measure the performance of applying the systems approach versus the non-systems approach, let's say?
Yeah, so when it comes to systems, of course, and especially cities, there are many different goals that you're going after, and carbon and climate change being a big one. But first it gets based in the city's values. So there's nothing that the technology is doing that can replace what the city and the citizens value as their priorities. So once that's said, and assuming that climate change is a big one of them, as we would expect, that the systems approach can go a long way to helping optimize not just in silos where you can get some local maximums and local peak performance, but optimizing across a system is one way that it helps. Another, just from the systems thinking standpoint, just from the type of things that we've gone over today, there's some great demonstrations by John Sturman, who's a big system dynamics person at MIT, where you can kind of show how failures of systems thinking can lead to bad policies or bad kind of gut reactions. So with the rates of changes in systems, for instance, you can get very smart students, politicians, et cetera, to map out on this computer software what they think the curve of emissions would need to be in order just to level out the amount of carbon in the atmosphere. 80% of them miss it. Even people who understand some of these concepts, they greatly underestimate the need to change the rate of flow into the bathtub, if you will, to match the rate of the flow out of the bathtub in order to get this leveling effect. And so from, yes, we can talk about optimizing and optimizing systems, but just at a systems thinking level, some of that's needed to even get to the policies that we need in order to meet those goals.
Right, and also the other part of that is that it's not only systems thinking, but it's also the ICT that you're bringing to bear to these urban problems, in a sense. And those enable you to monitor and evaluate operations in a way that we haven't been able to before.
Right.
And that in itself could bring about, much greater savings, whether it's in monetary terms or carbon emissions.
I mean, going back to well, my MIT days, a little bit later, the famous not Forrester?
Yeah,
Yeah.
Jay Forrester.
Jay Forrester, the urban growth dynamics model, which preceded the Meadows and Vanilla. There's quite a bit of excitement about those ideas that now finally kind of found their way of solving all the complex problems of cities. But then, as Hilda was pointing out earlier, not the requirement for the large-scale model, but also the two. One was the two planning theorists, Weber and Rickle, who wrote this thing about the wicket problem. And basically, they're arguing that the cities are two complex problems. That any attempt to sort of conceptualize the systems would obviously lead to failure. And the other more recent criticism, actually, is a very nice chapter written by my friend, colleague, Christine Boyer, about the two orders of cybernetics. She said the one order of cybernetics, the original cybernetics is very much what she calls machinic or mechanic. So they think of a city as a kind of a machine, and just like a locomotive engine or an airplane, and you can break it down into a system. That's one of the things about it. The other one is what she says has become much popular in the biological sciences, is the self-organizing system, the automoietic model. And so, and I think when he abandoned the old systems approach to planning, after Weber, little kind of argument, and well, the Churchman did a kind of a defense of systems, the systems approach and its enemy, something like that. Very nice rebuttal to that. But now there is a lot of kind of interest in this notion of the self-organizing system. Our colleagues in public administration and so forth, they also talk about that quite a lot. And but so I don't have really a position on how whether there is. I mean, I would say that ultimately you should judge it by some performance measures. If we're thinking about environmental issues or social outcome or something like that, does one approach give you a better handle than the other approach? I don't know whether you have some comments or thoughts on that.
Yeah, no, it's hard to know. I mean, certainly, there's other types of modeling, like agent-based modeling, and others that may address self-organizing systems, and a lot of them have been married to system dynamics approaches, so they don't necessarily, they're not necessarily exclusive of each other. But I guess it's to be seen what the appropriate approach is.
Yeah, I guess I should answer a little bit about the wicked problems challenge that Riddle and Weber posed at that time. I think the problems that they were focused on were systemic type of problems, and that's why they were wicked problems. And so if you are going to make some headway with them, you have to look at them from an integrated systems perspective, in a sense. And I think what Weber and Riddle identified were problems that were being approached in a very linear, siloed way, in a sense. And so I don't really know an alternative to that except a more integrated systems way of approaching these problems. Yeah.
They never talked about it.
That's right, that's right.
Question there.
I have two questions. First is, does the software or the system give the same model to different cities, or according to different data training, or is the same model that runs to other cities? Second question is, right now, how many cities are using the software?
So any new city that we bring it to, they require a fair amount of customization. So the model right now is calibrated to Portland, and includes some logic in it that may not even exist in other cities. If they don't have the same kind of transportation, light rail system, for instance, it wouldn't apply. We do talk about something called there's the extended model, which is what represents Portland, and something called the core model. And that we do have, that is the kind of physics, mechanics, city physics, if you will, that we think would exist in any city, that would be a starting point for any new conversation that we have with the city. So there's some repeatability to what we've done in Portland, and we've isolated those parts of it that we think are highly repeatable and those parts that we think are fairly unique. Now, this is the first of a kind of project, so there are not other cities that are using this model as of yet. We just came out with a press release around this, I think, in the July timeframe. But we're under discussion with several different cities about various aspects of the model, whether they'd want to do just a certain silo of it or a full-scale approach like Portland did. So something that's coming.
Jane? Good.
How long did it take to do the Portland thing, and how much data, how long did it take to collect the data, whatever that level you decided
Sure.
was appropriate? And do you really think if you came to LA, you could use anything from there to here?
Well, there's that, yeah. So, we did work with Portland over the course of a year. And it was the first time that we had kind of worked with the city, so there was a lot of things to work out, a lot of learning to do. Cities, depending on how different the city is, it's going to take a lot of additional work, and LA might be a case in point. But there's certain parts of this, like, we've written a paper on the Portland model that covers the city economic model. Very high-level model. A lot of it is just simply definitional almost in terms of how certain things flow in to create a GDP measure. And so, some of that kind of mechanic, by definition, would be applied to any city. But, when it comes to the stuff that gets really interesting, in terms of some of the unique connections and what makes LA different than any other city, that takes a lot of work and customization. And even if it didn't, even if somehow we were magically able to come in and instantly calibrate the thing, it would be the wrong way to go. You need to work with the people that have to use the model, with the experts in that city, not only to inform it and make it right, but to get that kind of trust that's needed and understanding of the model that's needed to get someone to actually use it in practice.
You said you have a small team that you're working with. I'm just curious the educational backgrounds, if you have some sort of dream team from all aspects of city planning or logistics or the technical
we
stuff.
we cover quite a lot of topics as well in addition to cities. So we're operating at this Smarter Planet scale. So we have pretty diverse backgrounds. There's a woman on my team who's currently getting her PhD right now in sociology and city planning at the London School of Economics on kind of a part-time basis.
Yeah.
We have there's a couple of MBA type backgrounds. It varies. We have a vice president who's kind of cherry-picked some people across the company. I see Amy behind you is smiling, so she knows what I'm talking about.
There's no magic behind it. It's literally takes a shopping cart and says, I want you, and I want you, and I want you.
Okay.
I was wondering what academic teams have you invited to follow the Portland project? Because this is obviously of more interest than just to city planners.
Sure. So throughout the process of constructing the model, we worked with some folks at MIT in terms of from a modeling standpoint, but we worked a lot with Portland State University, which of course is a local university and is very well known for its urban planning as well. There's a professor there, Ethan Zeltzer, and a few others that teamed with us sometimes in more of an advisory role, sometimes their students, for instance, were actively involved in helping with the project. So Portland State, MIT, and I think that model works very well, for other cities that we might engage with. That a local university partnership would be very beneficial. Was that your question?
Well, so you could be telling me about who is involved in designing the model. I'm more interested in who's looking at the results of the model, the behavioral changes resulting from the changes that you've made.
I see. So, you know, as of right now, there's no kind of follow-on research that's going on in conjunction with the model and its use cases. There's been different conversations about taking the model and instantiating it in the local university to let it continue to kind of change and evolve and drive some of that research. But as of now, it's not happening.
Okay, thank you. All right.
Go ahead.
Okay, I'm visiting scholar at East Asia Studies Center, Alison, and I know now there are about 30 cities in China. They apply the smart city as their strategy, and many of them cooperated with IBM. And I want to know what's your observation and the suggestion to these governments in China, and how to use system thinking to their job.
Yeah, I know IBM has quite a number of efforts going on and with different Chinese cities right now. A lot of them, we have a research lab, the China Research Lab, that's driving a lot of those initiatives. You know, I have to say that I personally am not close enough to any of those engagements to have specific feedback, except for to say that I know I've had some conversations. We've had a conversation with the head of the China Research Lab for IBM about this work and about systems thinking. So I think it's informing some of the projects that are going on now, but I'm, again, not close enough to be able to comment specifically.
Another question?
Yeah, I have a question about, like, do you think, or do you observe, like, how much does the city willing to invest in a system? I mean, under the tight budget right now, do you think are there many cities willing to go to this route?
Yeah, it's obviously a very tough time for cities right now. They're getting hit with budget problems from all over. The feds and the state governments that are normally supporting them are not giving them the same kind of resources. So it's and you know, if you have something that doesn't show, you know, direct material benefits, it's always a little bit of an uphill battle. But you know, mayors like Sam Adams or other mayors that are you know, looking at this issue have told us that, you know, if we're able to help them, you know, kind of better manage the resources, figure out how to provide better services to their citizens even in tight times, that would be something of use. But you know, I can't really comment on what cities would be willing to spend or not on this kind of stuff. We obviously, as a company, have been working with many cities to good effect, both in ways that are helping them reduce costs, but also in ways that are also helping them reduce or increase revenues in certain cases. So it's a project by project kind of thing.
We have one more question. It's a short question that requires a short answer. Then we have, because we are almost out of time. Well, if not, then please join me in and one to hand.